I wanted to do a short video on section 13.4, part C, what does latent heat do to the surroundings? And if we start, let's start by drawing the graphs that are in that section. We have pressure in this direction, and temperature in that direction. And air pressure is actually increasing towards the top, and this is kind of how we usually think about air pressure. But another way that you can think about it is in that direction is the upper, that's the direction of the upper atmosphere. So you could actually kind of draw this upside down to get a better idea of what goes on at higher altitudes. So with respect to pressure and temperature, though, the way that they are graphed here, we have three fields. We have ice, we have liquid, and we have vapor. So solid ice, water, and then water, vapor. So latent heat was that process of which we added or took away energy from the molecules. But that was not associated with a temperature change, it was associated with a phase change. So let's talk about this. Let's say that I have liquid water that's cooling down, and it reaches the freezing point, and that liquid water cools down. So liquid water right here, cooling down. That liquid water, in order to convert to solid ice, has to release energy to environment. It has to the process of converting liquid water to solid ice releases energy to the environment. So even though ice is forming, the surrounding, the immediate surrounding environment, however small that may be just the immediate air around a snowflake that's forming up in the atmosphere, that air immediately surrounding the snowflake actually gets slightly warmed up as liquid converts to solid ice. Contrast that with solid ice melting. So we increase the temperature of solid ice. You reach the freezing or melting point, and you have to continue to input energy into the system to convert from solid to liquid. So the process actually of converting from solid ice to liquid water pulls energy from the environment. So this, what I'm about to say, kind of feels counterintuitive, but it's 100% true. The conversion of liquid water to solid ice warms up the environment, whereas the conversion from ice to liquid, the melting of ice, cools the environment. And that same thing is true from liquid water to water vapor, and water vapor directly to solid ice. So as I said, a short little video, but if you remember this color-coded, if you go in the directions of the red arrows, even though the actual material, the H2O, is losing energy in that conversion from vapor to water or water to gas, the surrounding environment takes up the energy that's being released. So keep that in mind as we move forward.